So in continuation to our earlier discussion related to digital human modeling and simulation for virtual ergonomic evaluation, today we are proceeding for week 8 module, and in this module we will discuss some application of digital human modeling software in various types of products and workstation design, and after that we will move towards discussion of limitation and future research scope of digital human modeling software, and then also various steps which are needed to be taken towards widespread use of digital human modeling software, particularly in developing countries. So now we are going to discuss about application of DHM in different types of products as well as workstation design and its evaluation. So first we will discuss about a paper published by Sangjog et al. 2012. In this paper, the title of the paper is Design and Ergonomic Evaluation of a Shoe Rack in CAD Environment. Researchers demonstrated virtual ergonomic evaluation process using digital human models to confirm whether the CAD model of the shoe rack would really be acceptable to the targeted user and satisfy their real need in real scenario. So while people are or researcher or designer are planning to design a shoe rack, various criteria which are needed to be taken into consideration so that the design should be such that it should be preferred by the user and it will be very easy to use. So for that purpose, following a small user survey and brainstorming, researchers decided that few basic features should be incorporated in the design. So what are those basic features? So first they thought it should be usable for all family members of a small family. All shoes in each rack to be visible for someone standing in front. So if this is the shoe rack, so while someone is standing in front of the shoe rack, he or she should be able to visualize all the shoes kept in different racks in that shoe rack. Third, easy to move. Simplicity in use. So first, easy to move means there should be wheel or some other arrangement so that it can be dragged from one corner of the room to another corner as per the requirement, and it should be there should be simplicity in use. So its operational mode will be very easy or easy to handle, or taking the shoe, keeping the shoe back. So all these activities should be very easy. At the same time, tying shoelace. Compact and aesthetically appealing. The product must be compact and aesthetically appealing, so that people will like that product and there should be definite purchase intention. Then protection from dust, availability of proper clearance dimension, and inclusion of safety aspects are also considered as the design features in that particular product design. So here is that concept model. So researchers kept various provision. So from this image you can see the shoe rack is comprised of 8 inclined racks. So this side 4 and left side also there are 4 racks, and the racks are designed kept in an inclined angle so that if there is a lock, if you press that lock, automatically the rack will slide down and you can take your shoes and you can again push it back. Similarly, there is space, 2 different heights are there and there is some platform. So people of different age group can keep their feet on this space and can tie their shoelace. Then as I mentioned, wheels are there so that this can be moved from one corner to another corner of the room as per the requirement. Similarly, at the back side also there is some rubber padding and it can be kept against a wall so that during tying the shoelace it should not rotate or it should not topple down. And there should be also lock on the wheels so that it can be fixed. and the whole structure will be covered with the polythene or some other sheet, so that it can be all the shoes, all the things which are kept there can be protected from dust. So in this various aspects, design aspects are considered for during the designing of this shoe rack. So how the design processed, how the design and development took place. Users survey and followed by a brainstorming for the concept generation. That was happened. Next, video recording of the subject's postural behavior while they are putting or removing the shoes in various scenarios. So, first user survey for getting various types of insight about the requirement, then the design limit selection, and followed by brainstorming that what should be the concept model of the shoe rack. At the same time, during user survey also, video recording are carried out to understand the user's behavior, how they keep the shoes or how they take it out. So, all those aspects in different user scenario are also recorded. Then, based on that brainstorming, one various CAD model, 3D CAD model was developed, and out of this CAD model, one CAD model was finalized based on the various analyzing the various features. Next, for evaluating that CAD model of that shoe rack with digital human model, 5th percentile female, 50th percentile pooled mannequin, mean this is the combined data of male female. So, 5th percentile female, 50th percentile pooled data mannequin and 95th percentile male mannequins are generated. And these mannequins represents Indian anthropometric data of civilian population to justify the design for Indian users. And for this purpose, ergonomic design and analysis workbench of CATIA software was used. Following that videography, researcher understood how to the user scenario and accordingly proper interfacing of the digital mannequins with the CAD model of the shoe rack following appropriate working or functional posture. That interface was done. First, that digital mannequins are given appropriate working posture or functional posture, and then it was interfaced with CAD model of the shoe rack. Then various types of ergonomic evaluation are carried out. These ergonomic evaluations include vision analysis, reach or accessibility analysis, postural load, activity analysis like tying shoelace, etc. Now, here are few images. From these images, it is visible that while that 5th percentile female standing in front of the shoe rack, she can visualize the rack clearly. So, from vision analysis, it is very much visible. Similarly, while the person 95th percentile male standing in front of the shoe rack with the 30-degree view cone, he can see most of the shoes, and little bit neck movement, he will be able to visualize all the shoes. Here it is shown that while some person is sitting on the ground and opening the bottom cupboard, then how is the vision? So, he or she is able to visualize what are kept inside. Similarly, reach were also evaluated for 5th percentile female as well as 90th percentile male in different postural condition, either seated in squatting posture or half bent or standing. So, various types of reach analysis are performed. Then, as I mentioned earlier, different user scenario, particularly while those persons are tying shoelace, different percentile, 5th percentile female and 95th percentile male, while they are tying shoelace, keeping their foot on the shoe rack, then how is the scenario, how is the body joint angle, that was also measured. So, following this analysis of the shoe rack from various ergonomics aspects, researchers highlighted the relevance of digital human modeling software in identifying fit to the product to intended user during product conceptualization itself. So, instead of making the actual product or actual physical mock-up, it was possible by the researchers to validate the design concept in terms of ergonomic aspects in virtual environment. Now, moving to the next paper by Uday Kumar et al. 2013. The title of the paper is Proactive Ergonomics through Digital Human Modeling and Simulation for Product Design Innovation. This is a case study. So, in this case study, researcher proposed an innovative model of ergometer. So, what is ergometer? Which is intended to be installed in open space like park. So, ergometer are the exercise equipment which generally people use in different types of for gymnasium or in different types of exercise places. So, they keep this type of instrument for regular physical exercise. So, in this paper, researchers reported the concept model of a ergometer and also how that ergometer design was conceptualized and evaluated with digital human modeling software for various ergonomics aspects. Intended design was planned to be unique in look, aesthetically appealing, compatible for both adult Indian male and female, easy to use, and most interestingly, it would be motivational factor for people to continue their exercise for longer duration. Now, why they will be motivated? Because researchers thought that the people would feel happy because more battery which is inbuilt, battery recharging would happen if they go for intense and longer duration exercise. So, while the user is doing exercise on the ergometer, then the battery kept inside this bottom portion. So, that battery will be recharged and that energy or that stored from that battery that recharged battery will be used for illuminating the park in night. User survey and brainstorming was also carried out for like the earlier case for developing the concept. Developing a 3D CAD model using CATIA software of the ergometer from the final concept. Among various concepts, one concept was finalized and 3D CAD model of that concept was made. So, now how was the concept? So, like normal bicycle, so while bicycle pedaling is going on, then this, if you look at this circle, then the pedal actually moves like this. The same dimension or the same circumference was also used in this case for the pedal movement. So, ratchet to the scale of line of the pedal. So, in case of cycle pedal, what is the path for movement? The same circumferential dimension has been used for this motion of the pedal of the ergometer. So, in this image we can see various components of the proposed ergometer. So, this is the seat, this is pedal, and at this place dynamo and battery unit. Then this is the height of the hand grip from the ground, then this is the handle and this is the seat height, and seat height is also adjustable, so that we can various percentile or people with different dimensions, shorter or larger, they can sit and they can adjust as per the requirement. For accommodating a wide range of adult Indian population, 5th percentile female and 95th percentile male body dimension along with 50th percentile pool body dimension, which is the representative of average individual, are selected for this purpose, and digital human model for all those 5th, 50th and 95th percentile mannequin are generated using CATIA software. After developing that CAD model of the mannequins, then for different joints, comfort angles are rendered, so that when the body joint will move beyond the comfort range, it will show with highlighted colors. Proper interfacing of digital mannequins with CAD model of the ergometer following appropriate working or functional posture are given. Ergometer was evaluated and subsequently design was modified by providing more human-centric input. Various adjustable feature of the anthropometric compatibility, easy reach towards handle, clearance dimension, inputs for riding comfort, etc. So these various ergonomic aspects are considered during the design and modification of the ergometer. So if you look at these 4 images, so in every case there are 5th percentile female, 50th percentile pooled human mannequin and 98th percentile male. So these are the 3 human models. In all these 4 images, these are there. So first, it is seen that all the human models are in green color, means their body joints are in comfortable range of movement. So while their left leg at the bottommost position of the pedal, then this is the scenario. Similarly, while the left leg or left foot at the rearmost position of the pedal, then this is the scenario. Similarly, for topmost position and the forwardmost position. So in all these cases, how is the scenario that was studied, and accordingly body joints angles are measured, and it was found that this is within the comfort zone, which was defined and indicated by green color. Researchers also analyzed reach for all the percentile human models and found that the handle can easily be reached by all percentile people, particularly that shorter 5th percentile female. They can easily access the handle. One problem was noticed during the evaluation that due to as the space in between the handle stand and this ergometer, the space was very less. For that purpose, there is chance of interference, and at the same time the who is doing the exercise, he or she has to move their leg from, they have to lift their leg and move from one side to another during the ascending or descending process, and this is highlighted with red color. So while they are lifting their leg to move it from one side to another side for either for ascending or descending, so that time their body joints is, this leg is highlighted with red color, means there is discomfort. Postural discomfort during ascending or descending the ergometer are identified, and alteration of the handle stand design was done by providing sufficient clearance space for easy mounting and descending. So earlier it was straight, now following this analysis, while it was found that this space is insufficient and person has to lift their leg from one side to another side, then this space was increased. Now after modification of the handle stand, it is easy for the people to take their leg from one side to another side and climbing or ascending or descending down from the seat. Researchers claim that the final abstract concept design of that model of ergometer was validated virtually for human-centric design. So this is the final concept. So in this last 2 papers, so one is related to Surak design, and in this case it is the design of ergometer. In both the cases, we found that digital human modeling software can be effectively used for design and ergonomic evaluation of various products, and also we can ensure that wide range of people with varying anthropometric dimension, they can be accommodated. Next research paper is ergonomic evaluation of knapsack sprayer used in agricultural application by Bhuse and Vavehare 2014. Researchers carried out ergonomic assessment of knapsack sprayer, which is commonly used by farmers for spraying insecticide and pesticide. Following analysis in CAD software, physical prototype of the knapsack sprayer was made and tested. So they not only evaluated in virtual environment, they also made the actual prototype, and that was tested. Digital mannequin of 5th and 95th percentile are developed from 33 anthropometric parameters of male agricultural workers from 4 districts of Western Maharashtra, India, using CATIA V5 software. So, using CATIA V5 software and this anthropometric database, they developed 5th and 90th percentile male model of agricultural worker. CAD model of the most popularly used knapsack sprayer was developed using CATIA. So, this is that model with various components. Existing sprayer model with tank, stand, handle, straps, etc. And this is the lance model of the existing sprayer. Various postures of farm workers during the operation of knapsack sprayer are studied using human activity analysis and rapid upper limb assessment tool of the CATIA software. So, from this image we can see that while the operators are using that sprayer, they actually need to operate this handle, stroke handle, and it has 3 different positions. The topmost position, and this is the body joint angle for the joint angle for hand. Similarly, middle position, and this is the lowermost position of the handle. So, in different position and for the different activities, the simulation researchers simulated all those conditions. So, postural variation of hand as per the movement of the stroke handle. Following ruler analysis for left and right side of the body, design modification of the handle and lens are done. So, this is the modified design. This is for the modified design of the handle, and this is for a lance model. So, lance handle and this is the stroke handle. So, both design of both the things are modified. Suitable handle length 952 mm for 95th percentile digital mannequin and 493 mm for 5th percentile mannequin are considered, and a ruler score are calculated using CATIA. Physical validation was carried out by comparing the use of existing model and the modified model using overall discomfort rating by 5 operators. So, after modification of the components, they tested the design with compared the design with the existing one in terms of comfort, and for that purpose they collected ratings on overall discomfort rating scale from 5 operators. So, this is after modification of the design. Now, how is the posture and how the activity is being carried out. And this is the original prototype after modification. Higher ratings are found for improved design consisting of adjustable handle length, adjustable angle of grip, modified lens and nozzle. So, after collection of the rating from this overall discomfort rating, it was found that operators gave higher rating for the modified design or new design. Researchers concluded that an ergonomic well designed hand tool improves the user posture, and it is possible to make ergonomically sound hand tools using digital human link software and analyzing ruler. So, this is showing that with that modified design, the real prototype is being used by the worker. Next is actually this is a part of a thesis by Patel et al. 2015. In the thesis entitled Virtual Ergonomic Evaluation of Design Concept of Manual Portable Paddy Thresher Suitable for Agricultural Need of the Northeast India. So, in his thesis Patel et al. 2015, they described these issues, that virtual ergonomic evaluation. In that thesis, so many collecting from anthropometric data and so many other areas have been covered, but particularly in this slide we want to discuss this virtual ergonomic evaluation of design concept of manual powered operated paddy thresher. And this was designed for agricultural needs of the Northeast India. So in this thesis or in this particular part of the thesis, researcher developed a CAD model of a portable pedal operated paddy thresher through virtual ergonomic evaluation considering contextual need and topogeographical condition of the northeastern region of India. So this is the existing CAD model of the existing thresher, and this is the modified design. Mechanical design feature of Delmia digital human modeling software was used to generate CAD model of the existing and proposed thresher, and as it is shown here. Total 6 digital human models, 5th percentile, 50th percentile, 95th percentile, both male and female. So these 6 digital human models are generated, which are the representative of smallest, average and largest dimension of the targeted population, and this targeted population was Assamese farmer population, from the state of Assam. Proper interfacing of the digital mannequins and CAD model of the paddy thresher featuring selected working postures are achieved using ergonomic design and analysis feature of Delmia software. So these are the 3 female models and these are the 3 male digital human models of farmers, and those are based on their working posture, those are interfaced with the CAD model of the existing thresher as well as newly developed thresher. Comfort range of motion of joint angles are also rendered over the digital mannequins for posture evaluation. Generative structural analysis in Cosmol multiphysics software was carried out in order to predict deflection and stress distribution for the relevant components of the CAD model of the thresher to make sure that it could sustain the applied load. So this is the structure, the main structure of the newly developed paddy thresher, and that finite element analysis of the proposed thresher are carried out. And here load was applied, and based on that it was checked the total displacement as well as the strain. Posture of the mannequin during simulated threshing operations are evaluated based on body joint angles in relation to the comfort range of motion. So while the users are using existing paddy thresher, that is the old design, 5th percentile female, 50th percentile female and 95th percentile female. From the color coding it appears that 95th percentile female is not comfortable in operating because the height is relatively low for them and they need to adopt bending posture. On the other hand, the existing model is suitable only for 5th percentile female, but not for 50th percentile male and 95th percentile male. But while the design was modified and various other issues regarding less force exertion and all, and compact design, then proper cover, then it was found that new dimension of the thresher was anthropometrically compatible with the user population. So starting from 5th percentile female to 95th percentile male, for everybody it is comfortable, they can use comfortably and they need not to adopt bending posture, so as it is indicated by yellow color. But in earlier cases it was for 95th percentile female as well as 50th percentile male and 95th percentile male, it was in orange color. The model of the existing pedal thresher was found anthropometrically compatible for 5th percentile, 50th percentile female and 5th percentile male mannequin only, whereas newly developed thresher was found compatible for all mannequins used for the evaluation. The absolute values of L4, L5 intervertebral disc compression are found to be lesser for the newly developed thresher compared to the existing one. So in all the cases, for the old design as well as the new design, intervertebral disc pressure at L4 L5 level are measured, and it was found the amount of intervertebral disc pressure is less in case of new design and compared to the earlier one. Following virtual ergonomic evaluation, researcher concluded that the proposed design of pedal operated paddy thresher would be acceptable to the prospective users, and it would satisfy their need in real scenario without compromising comfort and efficiency. So after discussing these four products model related to, one was shoe rack design, another was ergometer, then we discussed about the knapsack sprayer, then paddy thresher. Now we are moving to few case example of some workstations. So first, all these are, now whatever we are going to discuss, these are actually not reported. These are summer internship project by different students. So first project is related to design and virtual ergonomic evaluation of a boardroom using digital human model. This was done by Bora and Rajput in 2013. So researchers demonstrated design and virtual ergonomic evaluation of boardroom accommodating 50 persons with varying anthropometric characteristics using digital human modeling feature of CATIA software. The boardroom design was purely based on the use of Indian anthropometric data with due consideration of dimensional compatibility and comfort. So these are the different view of the boardroom, where the 50 chairs are there, and this is the main table, and this is the projection board. Then this side, two doors are there, one this side and another is this side, and this is the inside view, where there is podium, and this is the chairs arrangement. Now individual components of the boardroom are designed as it is appears from this one: the main table, then all the speakers, then chairs, podium stand, then dais. So all these are CAD model of all these components are developed and evaluated with human model. So while 5th percentile human model is using this podium, this is the posture. Similarly, this is for 95th percentile male, and this is the visibility. While person is standing on the dais, so how much area of the room he can see, that is visible here. Similarly, while the people are seated side by side, how much is the gap in between two persons? So it was found that sufficient, or the chairs are arranged in such a manner that the space in between two persons is sufficient. From this image it is also visible. So if we look at the table was designed in such a way, these are the displays kept at an angle below the table surface. Table surface is transparent. Below the transparent table surface, these are the displays kept at an angle. So from here it is very clearly visible. So person is seated on the chair, and these are the displays, and this is the table surface, transparent table surface. So they are keeping their hand on the transparent table surface, and below the transparent table surface, these are the displays arranged. So they can see, instead of looking or bending the neck to the main display board, they can also see the same information on the displays kept below the table surface. And here from this image it is also visible that there is sufficient thigh clearance. Then the height of the dais, that was also evaluated. So for ascending or descending by smaller person, is also possible. Then the door dimension of the door nearby the podium as well as another door, it was studied and it was found that the door dimension is sufficient for the main door. Two persons side by side, 2% of larger body dimension be 95th percentile. With their bideltoid breadth, they can easily pass side by side without any collision. Then visibility are also evaluated. While the person is seated on the chair, they can with 30-degree view cone or even 15-degree view cone, they can visualize the display kept below the table surface. Then regarding the circulation space at the middle of the table, so in between two rows, the space is sufficient for one person to go and performing his required activities. So circulation space around the table was found sufficient. Now from this image, it is visible that while the person who is seated nearby the podium, that person while he is looking at the main screen or main display, so that this is that person and this is the binocular field of view. So it is completely covered. So within his binocular field of view, the board is or screen is coming, and this is shown in through eye view windows, that how much is the visibility. Similarly, the person who is sitting away from the podium at the end of the room, he can also visualize with binocular field of view, and this is the eye view window. Within 30-degree view cone, he can easily visualize the board. But for this purpose, neck movement and also posture, you can see he has to rotate little bit. So for that purpose, this type of displays below the table surface has been provided. So this is, as I mentioned earlier also, these are the student project. So they tried to develop the CAD model of the conference hall and various human factor issues they tried to evaluate using digital human modeling software. The next project, it was by Patra and Padhi in 2016. In this summer project, they carried out research on ergonomic design intervention for easy unloading and delivery of gas cylinder from gas carrier vehicle. So researchers demonstrated using CAD and digital human modeling simulation the design concept and processes of how gas cylinder unloading and delivery can be done in a more comfortable manner. So this is the gas carrier vehicle where the gas cylinders are stacked. So this is the CAD model of that, and it is showing that how they will bring the gas cylinder on this particular the trolley which is attached with the tailgate, and it will be lowered down. So mechanical design feature of Delmia digital human modeling software was used to generate CAD model of the gas carrier vehicle and accessories. 3 digital human model, that is 5th percentile, 50th percentile and 95th percentile male, are created to represent smallest, average and largest dimension of the Indian civilian population. So 3 digital human models, all are male created. Mannequins are interfaced with the product using human activity analysis submenu of the ergonomic design and analysis workbench in CATIA software. Next, selected body joints of the mannequin are given preferred angles or comfort range of motion for postural evaluation. CAD model of the vehicle tailgate with attached trolley are evaluated for various ergonomic issues like posture, vision, reachability, L4, L5, intervertebral decompression and shearing force, etc. for different operational scenario. So they demonstrated the whole evaluation in 5 scenarios. So first, lowering of the tailgate. Next, putting the cylinder on the tailgate by rolling it. Then lowering the gas carrier or the gas carrier trolley and detaching it. After that, moving the carrier on the plane surface. It may be moving the carrier on the stairs. So accordingly, they design the trolley or carrier in such a way it is movable on plane surface as well as the same it can be used for ascending or descending on the stairs. So these 5 scenarios they evaluated, and each scenario these various ergonomics aspects like posture, vision, reachability, spinal compression, all these are analyzed. Lumbar L4 L5 compression and shear force analysis was done using CATIA's biomechanical single action analysis, and in none of the scenario this compression and shear force cross the allowable limit except in scenario 3, particularly in this case during the lowering of the gas cylinder carrier and detaching it. So only in this case it went the spinal compression and shearing force went beyond the acceptable limit or beyond maximum permissible limit. In other cases it was within the permissible limit. Following reach and vision analysis, it was found that there was no problem regarding reach and vision for various percentile mannequins. So here are the scenarios. For each scenario, vision analysis, scenario 1 as we have discussed in earlier, lowering the tailgate. At that scenario, reach and vision, although it is not shown here. So then spinal compression, then posture, as from the posture you can see all the body parts except the hand is in green color. This is all the body joint angles except this shoulder one is within the comfort range. But in case of scenario 2, it is also comfortably done. Vision is also sufficient and reach is also the cylinder and the carrier can be reached easily. In scenario 3, many of the body parts are with red color. It means beyond the comfort range of motion. So although this is a momentary activity, so it will not create that much problem, but if some design modification can be done, then this will be good to avoid any musculoskeletal disorder or any problem related to disc pressure also. In scenario 4, carrying on the plane surface, so it was comfortable in terms of their vision, in terms of their reach. Similarly, in scenario 5, during ascending or descending on the stairs, so in terms of vision, reach and other ergonomic aspect, it was found no problem was found. Lumbar L4 L5 compression and shear force analysis was done using CATIA's biomechanical single analysis, and none of these scenario this compression and shear force cross the allowable limit except in scenario 3 as we discussed in earlier slide. Following reach and vision analysis, it was found that there was no problem related to reach and vision for all percentile mannequins. So in this way, these researchers during their summer project, these are very small project, and with that project those students tried to understand that how digital human modeling software can be used for designing the product or the process and how it can be evaluated for various types of operational scenarios. Next, we are discussing another small project by the students. It is on ergonomic design and evaluation of conference hall in virtual environment. So all these summer projects are actually unpublished. So reference are given at the end, but these are not published. So it will not be able, students or other people will not be able to access this one. Researchers demonstrated. So this is being discussed to give the students who are going through this course on digital human modeling, then you will get a fair idea about how for your own purpose you can use CAD and digital human modeling software for virtual ergonomic evaluation. So next we are discussing ergonomic design of a conference hall. So for that purpose various human factor issues are considered, and each and every component starting from chairs, podium, stairs, board, dais, everything, all the components are designed individually as per the human compatibility, and those are arranged inside the room. So researchers demonstrated the design concept of a conference hall and its ergonomic evaluation in virtual environment using DHM. Concept model was evaluated with 5th, 50th and 90th percentile male and female mannequins developed from anthropometric data of Indian population. So this project, small project, was carried out by Parinav and Pavan Kumar. So individual components like chair was designed and various dimensional requirement are evaluated using various percentile human models like 95th percentile female model for seat width, then 50th percentile mannequin for seat height. So in this way, using various percentile digital human models as per the required dimensional evaluation, the chair, CAD model of the chair was evaluated and model was finalized. Similarly, model of the podium was designed, and in that podium model, interestingly you can see these types of steps are given there which can be kept out and brought out from this bottom portion, and on that the people with shorter height can stand. The people with larger body dimension or larger stature, they can stand on the ground, but whose body dimension is shorter, they can use this type of supporting steps which are kept there or stacked at the bottom of the podium. So for 5th percentile model, it is shown here for 5th percentile model, 5th percentile mannequin or 5th percentile people can use this type of step or this type of platform to achieve optimal height of the podium. But larger people, they can directly stand on the dash surface. Then inside that conference hall, for various steps, how is the height and whether the space is sufficient for movement of the people, those aspects are also evaluated. From this image, it is visible that while the chairs are arranged in block form, so in between two rows of chair, the space is sufficient so that 195th percentile of people with larger body dimension can easily go inside and come out. So here you can see the chair arrangement, and in between two block of seats or chairs, the space is sufficient for movement of at least two people side by side with larger body dimension. So that is also shown here. So in this way, various aspects of the conference hall design are evaluated by these researchers, and based on that they finalize their design concept. And these are the references. As I mentioned earlier, these last few summer internship projects, those are actually not published, and these are very small projects, and we discussed here to give some idea about how students in their small project they can consider and they can use digital human modeling software for product or workstation evaluation.